Welcome back, dears. Today in chapter 5.1, we've got parallel lines. So, postulate is true without proof, but theorem is a statement that is proved based on postulates or some other theorems. First of all, we have to know what is a parallel line. So, parallel lines are those lines that they never intersect. They go on, but they never intersect. Take a look at line M and line L. Those are called parallel lines. They're so close to each other and yet they don't intersect. All right, dears. Now we've got a postulate. So the postulate, it says if two parallel lines are cut by a transversal, so in here line M will be the transversal for them, then the pairs of corresponding angles are congruent to each other. So let's say I have got line L and M are parallel to each other, and line N, it's the transversal that cuts those two lines. What will happen is that angle 1, take a look at the red parts, please. Okay, angle 1 and angle 3, those two will be congruent to each other. That means if this one is 50 degrees, this one will also be 50 degrees. All right. Now, angle 6 and angle 8, again the red ones, angle 6 and angle 8, they will be congruent to each other. So as you can see, two angles that there's another angle between them, okay, the two other angles will be congruent to each other. By what? By a postulate that says if two parallel lines are cut by a transversal line, then the pairs of corresponding angles are congruent. So the red parts are called what? Corresponding angles. What about the blue ones? Take a look at the blue ones, which is angle 2. Again, there's angle 3 between them and angle 4. So 2 and 4 also, they're called corresponding angles. They're going to be congruent to each other. That means if let's say angle 2 is 30 degrees, angle 4 also will be 30 degrees. Angle 5 and angle 6, as you can see, there's an angle between them. Okay, those two also will be congruent to each other. Whatever the number is, they will have the same answer. All right, dears. We also have something else. It's called theorem, which is alternate interior angles theorem. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Again, angle 2 and angle 7. Take a look here, dears. Angle 2 and angle 7. All right. Angle 2 and angle 7, those two will be congruent to each other. All right. It's like having scissors. All right. The scissors that we will get, we will have what? Like vertical angles. So here, as we can see, it said what? Alternate interior angles. So angle 2 and 7 will be alternate interior angle, and also angle 3 and angle 6 will be alternate interior angles. That means they will be congruent to each other. Those, they will be having the same measure. All right, dears? Now, we have something else. It says what? Same side interior angles theorem. Whenever I have got angles on the same side that there's no angle in between them, these will be called what? Same side interior angles, and they're going to be supplementary. What does supplementary mean? Supplementary means the measure of those two angles, their sum will be 180. Now take a look at angle 2 and angle 3. Angle 2 and angle 3, they're like siblings, exactly beside each other. There's no angle that's separating them. So I'm going to say angle 2 plus angle 3 will give me 180. They're going to be what? They're going to be the same line angles, and they're going to sum up to 180. And here the same thing is correct for angle 5 and angle 1. Exactly, they're on the same line. There's no angle between them. It's only 1 and angle 5. So I'm going to say angle 5 plus angle 1, it will give me 180. 80. By what can I say this? By what theorem? By same side interior angles theorem. All right, dears, let's solve this example. I have got angle L and angle M. Those two, sorry, line L and line M. Those two are parallel lines that they never intersect each other. It says find each measure. So if I have angle CBD, which is 55. So what is the measure of angle BBDE? So again, this is also going to be how much? It's going to be 55 degrees. Now take a look here. So here for A, they were called what? Alternate interior angles. Okay, take a look at this example. The question is asking you to find each measure, not find x. But first step, I have to find x, and then I have to evaluate for x, whatever I get. Now, in here to answer, they're both on the same line, and there's no angle between them. So I'm going to say 13x plus 23x, it's going to give me how much? 180. Let's start solving it, students. Now, 13x plus 23x equals 180. All right, 13 plus 23, how much I'm going to get? I'm going to get 36x equals 180. Now, I have to find the x, so I'm going to do division. What do we have and what do we do? I've got multiplication, I do division. Divide both sides by 36. Now, both of them, I can divide them by 6. Let's see how much I'm going to get when I divide both of them by 6. Okay, for the denominator, I'm going to get 6. For the numerator, I'm going to get 30. Now, 30 divided by 6, I'm going to get 5. This is not the answer of the angle. This is the answer of the missing variable, which is x. What I'm going to do is that I'm going to evaluate for the x. So I'm going to say 13 times 5 for the first one. And for the second angle, I am going to say 23 times 5. When I do this, I'm going to find the measure of both angles. Now, 13 times 5, I'm going to get 65, all right? And 23 times 5, I'm going to get, so 23 times 5, 5 times 3 is 15, 10, okay, 11, so 115. These two are the measures of those two angles that they asked for. Be careful, students. First step, you have to know that those two angles are supplementary. There is no angle between them, so they sum up to 180. This is the first step, which is the most important thing. Okay, the yellow part. After this, I find the x, which I found it was 5. And after finding the x, I have to evaluate it to find the measure of the two missing angles. So I'm going to say 13 times 5 for the first angle and 23 times 5 for the second angle.